Okay, this is going to be exponential and logarithmic equations. So remember when we were converting from log to exponential form, and sometimes we had the variable in the exponent, and I said, well, you might be able to guess what this is, but there is actually a way you can algebraically solve this, and it's all regarding taking the log of both sides. Well, that's what we're going to do. So we're going to solve equations with the variable as the exponent. Okay, so let's look at a couple of these examples. For starters, we'll have to solve this equation, like 3 to the power of x equals 4. So if you remember, the lesson we just talked about was the properties of logarithm. And one of the properties was this: log base b of m to the n, I think that's how it was written anyway, is equal to n log base b of m. Alright, so really when you take the log of both sides, the property says you can take that exponent and move it down in front. So in this case, our exponent is unknown, and 3 to whatever power, I have no clue what it is, that gives me 4. So I am going to write the log on both sides. So I'm going to have log of 3 to the power of x equals log 4. Because what you do to one side of the equation, you have to do to the other. And because of this exponent here, I'm going to use my property of logarithm, and I'm going to bring it down in front. So it's going to be x log 3 equals log 4. Now this is a number. Log 3 is a number. Log 4 is a number. So really I have x times a number equals log of 4. If I had x times 2 equals 4, what do I do to solve for x? Divide both sides by 2. So in this case, what do I need to solve for x? We're going to divide both sides by log of 3. So that cancels, and I end up with log 4. Oh, I can't do it with these calculators. So I'm going to do log 4 divided by log 3, and I will get probably some crazy decimal. I do. It is about 1.2619, rounded to the nearest 10,000 place value. Okay, so vice versa, if I did then plug this to check, if I did 3 to the power of 1.2619, I get 4.00017779. Right, since this was an estimate, it was about. So when I plug that in, it's going to equal about 4, which it does. Alright, let's look at example 2. If you feel like you have a good grasp of this, why don't you pause the video, try this one. So for this, again, take the log of both sides. And then doing that, I can use my property of exponent and bring my exponent down. So it's going to be 2x log 6 equals log of 21. You can do this a couple different ways. Because you know that multiplication is commutative, you could move this around and divide everything by 2 log 6, 2 times log 6. Or you might not see that. So what you might need to do is go ahead and divide both sides by log of 6. So we're going to have log 21 divided by log 6. Okay, so I get 2x equals 1.6992, rounded, so about. And that's what 2x equals, so I need to find what x equals. So I'm going to go ahead and divide both sides by 2. And doing that, I get x, again, is about 0.8496. And again, we can check. 2 times 0.8496 is 1.6992. And so I'm going to raise 6 to that power, and I get 21.007403. So really darn close to 21, but not 21 exactly. And then we can continue with this here. Again, pause the video and try this one. But this next one here, same concept. Take the log of both sides. And then now that I have a logarithm written there, I can rewrite it using my power property. So here, I'm gonna divide by log 3, because this is x plus 4 times log of 3. So we're gonna divide everything by log 3. The log 3 there will cancel, and log 101 divided by log 3 is 4.2009. Okay, and that's what x plus 4 is, so I still need to solve for x. I'm going to do that by subtracting 4. So this minus 4 is 0.2009, again, about. So if I plug that in, 3 to the 4.2009 power is 101.00402. Again, really darn close to 101, just not 101 exactly, because I rounded that decimal point. Okay, so that's what you need to do here.